Good morning everyone. I am Rihan Anjum. Currently I am pursuing my first BTech in Srinivasa Ramanujan Institute of Technology in Anantapur. Now I am going to talk about D flip-flops. Now we are going to discuss about D flip-flops, introduction, advantages, limitations, truth table and many more of D flip-flops. Now let us see introduction to D flip-flops. Basically, D flip-flops are a type of digital storage elements used in a sequential logic circuits, and it stores a bit of data and widely used in memory devices and registers, and the it captures the value of data input on a clock edge, making it synchronizes. So this is the main introduction of the D flip-flops, which is it is a digital storage element, and it stores a bit of data and mostly used in memory devices and registers, and the value of data input on a clock edge, making it synchronizes. And now let's see the basic operations of a D flip-flops. The D flip-flop has two stable states representing binary zeros and ones. On the triggering clock edge, the output takes the value of data input. The output remains constant until the next clock edge, ensuring stable output during that period. It means the output remains constant until the next clock edge. Now let us see the truth table of a D flip-flop. The truth table outlines the relationship between D input clock signal and Q output. When the clock signal is low, the output retains its previous state. When the clock signal transits from low to high, Q flows the value of D. You can see the truth table which is represented here. D CLK Q dash, which is in zeros and ones, 0 0 0 and then 1. This is the truth table, and that is the small diagram of the D flip-flop. Now let us see the timing diagram of D flip-flop. The timing diagram illustrates the relationship between the clock D input and Q output. Here D means input and Q means output, which you can see in the diagram which is represented there, and it shows how Q means output changes states in response to the clock signal and D input. And the time diagram is crucial for analyzing the performance of flip-flop circuits. You can see the circuit diagram here, which means Q means input, and which passes uh, which passes there, and we are seeing the input and output of a D flip-flop. This is the time diagram of a D flip-flops. Now let us see setup and hold times of a D flip-flop. Setup time is the minimum time that the D input must be stable before the clock edge. It must be stable before the clock edge. So hold time is the minimum time that the D input must remain stable after the clock edge. So the minimum time that the D input must stay remains stable after the clock edge, and these timings requirements can lead to unpredictable behavior in the flip-flops. And you can see the diagram which is a T setup, T hold, which means time holds, and D can changes here, and D can changes there, and it is going to stable. This is the setup and whole timings of a D flip-flop. Now let us see the applications of D flip-flops. D flip-flops are commonly used in shift registers for data storage and transfer, and they serve as memory elements in digital systems such as registers and counters. Their clock nature allows for synchronization in complex digital circuits. And let us see the advantages of D flip-flops. D flip-flops provides predictable and stable behavior essential for digital design, and they eliminate rare conditions that can occur in a asynchronous circuits. Their simple operations make them easy to implement in various applications. So these are the advantages of D flip-flops, and now let us see the limitations of D flip-flops. D flip-flops are sensitive to clock timing. So these are very sensitive to clock timings, and requiring careful design to avoid timing issues, and they require additional uh, circuitry for asynchronizes resets or enables, and the speed and power consumption can be limited factor in high speed applications. Now let us see variants of D flip-flops. These are several variants of D flip-flops, including edge-triggered and level-triggered types. Some D flip-flops include features like preset and clear inputs for added functionality. Understanding the different variations helps in selecting the appropriate flip-flop for specific applications. Now the conclusion is D flip-flops plays a crucial role in digital circuit design and or functional elements in memory storage. Their predictable behavior and essence of synchronization makes them invisible in modern electronics. Mastery of D flip-flops is essential for anyone working in the field of digital systems. So these all about the D flip-flops. So thank you for this opportunity.